So hi guys, welcome back to my channel. So from today onwards I'll be start explaining the design patterns. So for this video I'll be starting with the factory pattern. Okay, when I was creating this content, I've seen that for the creational design patterns there are 5 patterns that lie under this category, and among those 5 the factory pattern and abstract factory pattern are the most important. Okay, so let's start with the factory pattern. Okay, so just bear with me till the end, and at the end of the video I'll make sure that each and every points are very clear. What are the components that needed to implement factory pattern, why we need to implement factory pattern, without factory pattern how we use to code. Okay, everything I'll be explaining, so just have patience and be there with the video. So factory pattern is a creational design pattern that defines an interface for creating an object. Okay, it is defining an interface for creating an object, but let's subclass decides which class to instantiate. I know this definition is little bit vague, but let's move forward. Okay, object creation is delegated to subclasses instead of being done directly using the new keyword. Means the object creation is given to the subclass. Okay, is given to the subclass to decide that which objects to be created. Now without using the factory pattern, we'll see that directly create object using the new keyword. We'll see an example in which we'll be coding with the help without the use of factory pattern. Okay, depends on the concrete classes. Okay, and using if, else or switch to decide which object to create. These 3 points make the design tight coupled and violation of open close principle. What open close principle says is a class should be open for extension but closed for modification. Means if there is new requirement came, you can extend it, but you cannot modify that class. Okay, but here if the new requirements come, and just because we are using the new keyword and directly depending on the concrete class, we need to modify that class, so it violates the open close principle. Now let's move further. So what depends on concrete class means, okay, there is this class logistic service which is having one method service, and inside that we are instantiating a class using the new keyword directly. It means that my code directly knows what the real implementation instead of abstraction, and also you all can notice there is no abstraction here. Okay, so logistic service knows that delivery happens via truck. If tomorrow delivery might be done by ship, you must need to modify this class, and if you are modifying a class, that means you are violating open close principle. I hope this is clear. So this class is no more reusable. I have written lot of notes. Okay, you all can follow. It might be possible that I'll not be going each and every line of the notes, but I'll make sure that the concept will be clear. Okay, now depending on abstraction, so what I have done for the same class, if you'll see here, okay, I'll show you. So for the same class, what I have done here, I have implemented abstraction. It means that I can pass any of the class which implements this transport and call this method delivery, call this method deliver. Okay, now the service does not care what is truck, ship or plane. It works with anything that implements the transport, as I have told. Does not change when new transport type appears. Let's say for this example we are using the new truck. Let's say in future if the delivery is done by ship, I need to change this class, I need to modify this class. Okay, but for this, if delivery is happening via ship, then in the another part of the code I'll be just changing the implementation, that instead of truck I'll be doing ship, and dynamically I'll be passing the transport here. Okay, and calling this method deliver. So no need to change or modify this logic. Okay, I hope this is clear. Now we'll see the bad code. Okay, so in some part of the code, this all the dots will be connected very soon. Okay, so just bear with me. So if type is equals truck, then I'll be returning new truck. Else if type is equal ship, I'll be returning new ship. So every new type forces modification of the existing code. Let me take you through the example of code where we'll be seeing that without using the factory pattern how we used to code. Okay, so I have created a transport service which is having deliver method. So this service makes the delivery. Okay, now I want the delivery to be happened via truck. Okay, so what I have done, so I'll be passing the truck string inside the deliver. It will reach here, it will match truck, it will call the class truck and call the method deliver. Okay, so it will reach here and it will print delivery is happening via road. Same as with ship, I passed string, it will go if, else if ship, instantiate the class, call the method deliver, and it will call here delivering via ship. Okay, delivering by ship. Now if I'll run, you all can see the output. delivering by road and delivering by ship. Okay, I hope this is clear. But now if there is new requirement came, then again I need to modify this class if else and everything I need to do. So this violates the open close principle. So this is the example of one problem where we used to solve this without using the factory pattern. Okay, so now let's move to the UML diagram. Okay, so the client code is directly depending on the concrete class. Okay, client knows the concrete class, there is no abstraction, cannot extend easily. Okay, now with the help of factory pattern. Okay, so I'm just following the flow of the notes, that's why I'm explaining this, but don't worry, in the code these all things will be very clear and you all will be very familiar with all these jargons. Okay, so let's start. This is the factory. Okay, this is the factory. Okay, this is the main part and this is the factory method. Okay, now what's happen is whatever class that implements this creator need to have implementation of this. Okay, whatever class that implements this concrete or implements this class needs to have the implementation of this concrete product. Now you all have question that what this concrete product returns in concrete creator A and in concrete creator B. So this concrete products dynamically decides that which object to call. So it's obvious that if it is in concrete creator A, it will return the product of concrete creator A. This concrete product, just because this is in concrete creator B, it will return the product of concrete creator B. So now again coming back to the definition, object creation is delegated to subclass instead of being done by directly using the new keyword. Okay, defines an interface for creating an object but let subclass decide which class to instantiate. Okay, let's move here. Defines an interface to create an object but let subclass decides which object to be created. Okay, now I hope the definition is now getting a bit clear. This will getting more clear as you all can see. I'll be explaining different modules that is used to implement the factory method and all the code examples. I have taken 2 code examples. Okay, with factory pattern using the transport, with factory pattern using the payment. Okay, so just bear with me. Okay, and also don't get demotivated by listening these words for the first time, because in the code also I'll be showing each and everything and again I'll be coming back to the modules so that the revision is also done. Okay, so for the module 1 you'll see that product interface. Okay, let me open the code. So if you'll see, this is the product interface that I have declared, transport. It is having one method, deliver, solid principle, first principle. Okay, if you haven't watched my solid principle video, please go and watch. In that video I have explained each and every part and that too in very detail. The difference between interface, difference between abstract classes, when to use what, and what are concrete classes, what are the features of abstract method, what are the features of interfaces, everything. Now interface transport, I have declared one method, deliver. Deliver is related to transport. Okay, now responsibility is declare behavior common to all products. This deliver will be common to all products. No construction logic, no business logic, nothing but a blueprint. Okay, in product interface abstraction. Okay, now the key rule is if a method does not make sense for every product, it means that whenever let's say some class implements this transport, then the class must need to make deliver method, or then the class must need to implement this deliver. But if a class is nothing to do with deliver, then this deliver method should not be present in the interface transport. That is all it is saying here. If a method does not make sense for every product, it does not belong here. Okay, moving further, concrete products, how it is done. Okay, these are the concrete products, these two okay, these two are the concrete products. Why I am saying concrete product? Responsibility is implement product behavior, contains zero creation logic, no knowledge of factories or creators. At this point of time also it has zero knowledge of what is factory, what is creators, what is what is the business logic, nothing. It just implement this deliver, it just implement the transport and have the implementation of deliver. It means that let's say if I'll start writing, so I've written truck that implements the transport, and how delivery is happening, delivered via road, done. With ship, implements transport, it delivered via ship or delivers via sea. Okay, I hope this is clear. Now move to the third module of the factory pattern. Okay, the third module is the creator, where creation is declared. Okay, let me see here, it is the creator. Okay, so this is the creator. This is the core of the factory method which I have shown. Okay, let me show you. This is the main part of the factory method, okay, or the factory pattern. Okay, so what it does, let me go line by line. So I have declared abstract class logistics. Okay, let me move here. Where is the concrete creator? Let me first read the responsibility. Decide which product to create, override the factory method, isolate new keyword. Okay, let me see. So this logistic contains the planned delivery. Okay, so in the planned delivery, and also let me start from the first. Okay, so this abstract class logistic have one method which is having the implementation, one abstract method. So the class which extends this class need to have the implementation of create transport. This is the heart of this factory pattern, means factory method. Okay, now the implementation, what I am doing, public void plan delivery, it will dynamically call create transport, and it will dynamically bring the transport. Like I want to make the delivery happen via truck, ship, plane, etc., etc. So it is his overload that he needs to bring the object dynamically. Okay, and then with the help of transport, this interface, I can call this deliver. Okay, I'll explain the complete flow. Okay, just wait. So again repeating, concrete class who decides what to create. Okay, responsibility, decide which product to create, override the factory method, isolate new keyword. Okay, let me see, okay, so let me move forward. So logistic, there is the road logistic which extends logistic. Okay, road logistic which extends logistic. So by default it needs to implement the create transport, and just because it is the road logistic, it is returning the new truck, this concrete product. Okay, so this is the concrete creator because this is creating, okay, the product. That's why it is concrete creators. And just because it is returning the truck, okay, what it is, this is the concrete product, okay, which is related to road logistics. Now let me move above. Okay, so let's again look into this. So this is the factory. Okay, this is the factory method. Okay, so whatever class concrete creator that extends this class need to have implementation. Whatever class, okay, let me move a little bit up. Whatever class extends this logistic should have the implementation of create transport. Okay, and this concrete creator A will return the concrete product A, and this concrete creators will return the concrete product. Okay, truck, what is truck? If you go above, it is the concrete product. I hope this is getting clear now, a little bit clear. So similarly, C logistic, extend logistic, it need to have the implementation of create transport, and it is returning the concrete product related to C logistics. I hope this is clear. Now let's move. So concrete creators is also done. Now the last module, which is client, who triggers everything. Choose the creator, never touch concrete products, never call constructors. Okay, this is the client code. It never touch concrete products, it never touch concrete products, it never call constructors, it never call constructors. Okay, now let's see how this code is working. Okay, so this is step by step. I'll be explaining how this is working, how the code flow is working. So first thing, I have declared one abstract factory. Okay, object of abstract factory. At this point of time, I am deciding which concrete creators needs to be called. Okay, this is the only part where I am using the new keyword. Okay, I'll be clearing some of the myths also of the factory pattern, but for now let me explain. Okay, so logistics is equals to new road logistics. It means that new road logistics. Okay, and logistic dot plan delivery. Now where the flow comes, I have called logistics plan delivery. Just because road logistics extends logistics, so this default method will come here also. Okay, now let us assume that the flow is here. Now what happened? Okay, so JVM creates an object in memory and attaches a method table to it. Okay, so road logistic object in memory, there is the road logistic object in memory because we have passed the reference of road logistic in this class. Okay, now plan delivery is of logistics, which is the default. Plan delivery, which is of logistic, which is default. Create transport is of road logistic because every because every class must have the create transport, and plan delivery is common to all the class which is belongs to logistics. Plan delivery is common to all the class which is belong to logistics, and create transport should have or should be implemented in all the class which extends this logistics. Okay, I hope I am not going very fast. Okay, so you all can repeat the video and you all can listen it again. Okay, now so what's happening is logistic is equal to new road logistics, as you all can see, new road logistics dot plan delivery. Now inside the plan delivery, when JVM hits create transport, okay, when JVM hits create transport, it will ask, okay, from plan delivery it will ask who is this object right now. Means when it will hit the plan delivery, then it will ask this whom object you belong to. So we'll see plan delivery is called from here road logistic. So road logistics plan delivery means it will say that this belongs to the road logistics object. Okay, so it means that this plan delivery is called by road logistics. So create transport will be called by, so JVM looks at a road logistics method table. It will look at road logistics method table, and just because it needs to call the create transport, it will call the create transport which is inside the road logistics. Okay, so in the road logistics it will call the create transport, and in return it will get the truck. Okay, and we are storing inside the transport. If you'll see we are storing inside the transport. Why we are able to store inside the transport? Because truck implements transport. Okay, it is the fundamental of solid principles. If you haven't watched, you all can go and watch. Okay, so now in the transport will be storing the reference of truck. Okay, now just because this transport is of truck, you all can see transport is equal to new truck. Now truck dot deliver. Okay, so truck dot deliver, so it will call delivering via road. I hope this is clear. Now again I'll be explaining. Now logistic is equal to new C logistics. Okay, C logistics extend logistics. Okay, so first question is how we are able to store the object in the logistics. We can store the reference of object inside the logistics if logistic is implemented by C logistics. Okay, so C logistics is called logistic dot plan delivery. Okay, plan delivery is common to all the classes. Okay, so we'll come here create transport. Now JVM again asks whom this plan delivery belong to. It will belong to C logistics. Now it will go to the table, C logistic table, and it will see create transport, it belongs to C logistic. Okay, so C logistic create transport you need to call, and in return you will get the concrete product of ship. Now the point comes here, transport is equals to new ship dot deliver, delivering via ship. Okay, let me run this. Now you can see delivering via road, delivering via ship. Okay, so now if in future there is new requirement came that we need to do the delivery via air. Okay, so what will we do? Class logistics. Okay, so class air logistics, and inside this we can have the implementation of create transport. But the thing which needs attention is whenever the new requirements come, I haven't touched this, touched this means modified this, I don't need to modify this, I don't need to modify this, I just need to extend it. Okay, there is no modification, so open close principle is not violated here. I need to modify this. Okay, I do not need to touch this, so I just need to create a class plain and which implements the transport and have the implementation of deliver method. That's it if the new requirements came. Okay, so I hope this is getting clear. Now again I'll come back to this. Okay, again I'll come back to this modules. Okay, so module 1 says that product interface what is being created, declare common behavior to all products, no construction logic, no business logic. If a method does not make sense for every product, it does not belong here. I hope this is clear. This is the product interface. Now there should be some concrete products which implement this deliver also. So this is the concrete products, truck and ship. Okay, this is the product interface. These are the concrete products. Okay, moving further, the main heart of the factory pattern, which is the creator. This is the creator. Okay, if you all get confused that why I have used abstract, why I have used this keyword inside this, go and watch those solid principles 1 and 2. It will be very clear. Okay, so now inside the creator, where creation is declared, this is the core of the factory method. This is the core of the factory method. Now whatever class that implements this logistics or the creator need to implement this create transport. Now these are the concrete creators which return the concrete product. Okay, these are the concrete creator which returns the concrete product belonging to this creator. Okay, now truck, ship, it returns. Now in the client code, when I'll call the factory and initialize the concrete creators, it will in return dynamically return the concrete products, and through the concrete products I can call this methods, okay, which is the business logic. So now moving to the concrete creators, decide which product to create, override the factory method, isolate new keyword. Okay, fifth is the client code. Choose the creator means we need to choose the creator, that which creator needs to perform this delivery. Never touch the concrete products, never call the constructor. Never touch the concrete products, never call the any constructors. Okay, in the client code. Okay, I hope this is clear. So let me clear some of the myth of the factory pattern. So factory pattern removes all the new keywords. No, it's simply not. Why? Because in the client code we are using the new keywords just to decide which creator needs to perform all those operations. Okay, so it does not eliminate the new keyword, and factory pattern also does not guarantee that open close principles always remain sustained or untouched, okay, or not violated. Why? Because let's say in future if we want to add some more method related to transport, then we need to modify this interface. So it depends. Open close principle, here it is not violated in case of this factory, because if you see without factory, this is the factory, okay, which is producing the concrete products. But here again and again when there is new requirement come, we need to modify the class. Okay, but for this case we don't need to modify the factory. Okay, so it depends for which part the open close principle is not violated. So it does not protect interface changes, workflow changes or behavior changes. We need to modify. Okay, now the conclusion. Okay, this will be the conclusion. So then I'll be moving to the one more examples of the factory pattern, and then we'll wrap up this video. Okay, so in conclusion, the factory pattern recommends avoiding direct object creation. In conclusion, the factory pattern avoid the use of direct object creation. Okay, the new keyword in client code. Instead, the object creation is delegated to a dedicated factory method. Instead, the object creation is delegated means the object creation is delegated to the dedicated factory method. This factory method is responsible and it will dynamically see that which object or which product it needs to initialize. Okay, now the object are still initiated using the new keyword, but that instantiation happens inside the factory method rather than in the calling code. Okay, in the calling code we are directly using this. Okay, that use this if and else, use the new keyword directly. Okay, but instead here what we are doing in the client code is we are just initializing the concrete creators that go and decide which methods needs to be called or which product needs to be called. Okay, the object created and returned by this factory method are called products, as I've shown you. So the object created and returned by this factory method, the object created and returned by this factory method are called products. Okay, now let me explain this. Okay, so this logistic, as I've already explained, this logistic, this is the creator. Okay, this is the creator, this is the factory methods. Okay, but to be very specific, this create transport is the factory method. Now what it will do? Okay, so create transport, so whatever class that implement this logistic need to have the implementation of create transport. So C logistic need to have the implementation of create transport, and in return this create transport will return the object related to this road logistic, and in return this create transport will return the object related to this C logistic. So these are called the concrete products. These are the concrete creators. This is the factory or the creator, and this is the factory method. Okay, I hope this is clear. So now both truck and ship should implement the transport interface. You all can see here, both truck and ship should implements the transport interface which is happening. The factory method defines the road logistic class. Okay, the factory method defines in the road logistic class. The factory method defines in the road logistic class will return the product related to the truck object. The factory method implemented inside the C logistic part will return the object related to the C logistics. Okay, so when to use the factory pattern now? when the exact object types are not known in advance. Use this pattern when your code cannot determine beforehand which specific classes it needs to work with. Okay, so use the factory pattern when you are not sure in the initial stage that which objects you are gonna working with. Okay, it means that if you are not clear that what are the objects that I need to work in the future, then use the factory pattern, because it creates or lets the subclass decides dynamically which objects needs to be created. Okay, now moving further, the pattern separates the logic, okay, that create objects from the logic that uses them. Because of this separation, you can modify, extend the object creation logic without affecting the rest of the system, which I have already explained. Okay, now what are the advantages? Reducing tight coupling. The creator class does not depend directly on the concrete products. The creator class does not depend directly on the concrete products. Okay, support single responsibility principle, means all object creation logic is moved to the one dedicated place. Supports open close principle. We can introduce new product types by creating new subclasses without modifying the existing client code. Okay, I hope this is clear. Now let's move to the one example which is remaining for me to explain. Okay, so let's start one by one with the modules and let's fit those modules in this example. Okay, this is the payment gateway. What I'm doing, this is the product interface which is being created. Okay, this is the level of abstraction. This is the level of abstraction that I'm doing. Now where are the concrete products? Credit card payment, UPI payment, net banking payment. These are the concrete products which are implementing this payment gateway and have the implementation of this pay. Okay, paid via credit card, paid via UPI, paid via net banking. Now moving further, concrete products already explained. These three are the concrete products. Okay, these three are the concrete products. This is the interface. Now moving further, where are the creators? So this is the creator which handles. Okay, this is the creator. This is the core of the factory method. Declare the factory method contains business logic, work only with the product interface. This is the heart of the factory pattern. Now what it is doing, it is calling the process payment. Just because it is the default method, so it will common to all the classes which implement this payment service. Okay, so process payment will be common to payment credit card service, UPI service, net banking service. But this is the factory method which I have told, heart of the factory pattern. Okay, this concrete payment gateway will be implemented by credit card service, UPI service and net banking service. And this concrete creator, okay, creator is completed. Now concrete creators will decide that which product needs to be called. Okay, which product objects needs to be called. Okay, so credit card service is returning new credit card payment, UPI service is returning new UPI payment, net banking service is returning net banking payment. Now we will move to the client. Okay, choose the creator, never touch the concrete products, never call the constructors. Okay, so it is saying that I want to pay via UPI service. Okay, payment service, it is the factory. I am saying choose the concrete creator. Now concrete creator dot process payment, it will go inside this. Okay, it will go inside this. Just because this implementation is same, so it will be followed inside the credit card service also. Now when the line goes here, so create payment gateway, now it will ask that which class this object belongs to. So process payment is belongs from UPI service. Now UPI service create payment will be called. Now what will happen, it will return the UPI payment. So payment gateway is equal to new UPI payment. Okay, now just because it is of new UPI payment dot pay is called with amount. So UPI payment dot pay will be called and it will return paid using UPI. Okay, same as with credit card service. Now if we'll go to credit card service, it will see create payment gateway, which credit card, just because we have called process payment through credit card service, so it will say create payment gateway is of credit card service. Now return the credit card payment. So credit card payment. Okay, now when we'll see credit card payment dot pay amount, so it will go here credit card payment dot pay amount, so it will print paid amount using credit card. The same as with net banking service also. If I'll run this, you all can see the output. Nothing to be surprised. 5,000 via UPI, 10,000 via credit card, 7,000 via net banking. So I hope this is clear. Now again revising each and everything. So factory pattern is a creational design pattern that defines an interface for creating an object, but lets the subclass decide. subclass decide which object to be created. Now let's move to next point. This is the concrete, this is the factory, this is the factory method. Whatever concrete creators that implement the factory needs to have the implementation of concrete product, and this concrete product will be decided by the concrete creators which product needs to be returned. Okay, this is the notation just for the knowledge of the UML diagram I have written here. Okay, plus means public, minus means private, hashtag means protected, and this is the package. Now again revising this module 1, product interface, which is nothing but the interface. Okay, this is the interface. Let me show with this example. This is the interface. These are the concrete products that implement this interface and have the implementation of this deliver. Okay, this is the concrete product. So this is the creator, in which it contains the business logic and one factory method which is responsible for returning the concrete product which relates to this concrete creators. Okay, I hope this is clear. Now concrete products implementation, creator which contains the business logic which works with the product interface. Now concrete creators which decides which product to create, override the factory method, isolate new keyword. Now client code, from client code will be using the factory and will be using the concrete creators to decide which flow it should go in order to deliver this. Okay, so I hope this is clear. So this is it for the video for the factory pattern, and I hope I am able to explain all the points related to the factory pattern, and I hope I'll be able to explain all the modules or the components that used to implement the factory pattern, and I hope it will make easy whenever the new problem statement comes, whenever it requires to be implemented or to be designed by the factory pattern. You all can do one thing, you all can give the ChatGPT to give you 5 problem statements where you need to implement this factory pattern, and after implementing this, I don't think it will be any more tough for you to understand the factory pattern. So thank you for watching and having patience. So thank you so much.